In this lab, we are going to read the JSON data file where we are going to download, and then we are going to read that in R, and we're going to carry out some data analysis. So first step, read the JSON data from the file. Now this step over here, download the JSON data from the web page, download .file of bracket the web address, and is this one. It's a long one, and then we put that in double apostrophe comma, then we put the traffic, the name of the file that we want to give. So we want to give traffic dash daily dash counts.json, and we put that in double apostrophe sign. Now running this, this R Studio that I'm using is not big enough to read this file. So let me use uh, the console to read this file. Now to and we'll use the terminal part of it. So let's check the list of the files. So we already have the traffic dash daily counts dot JSON. So we're going to remove that. RM traffic dash daily counts dot JSON. Okay, now checking the list of the files again, ls-cell, so we don't see that file any longer. Now we're going to download this file here. So Control Shift V. So this is going to download the file. So let's do ls-l. No, it doesn't. So the other way to do it is we have R. Let's have a look. R 4.4.1. So we will use that to do that. So let's print that, and we see that is downloaded. Now we go back to this R Studio, this console, and let's check the list of the files. We see this traffic dash daily dash counts.json. Now we will check the first few lines of this file. Head traffic dash daily dash counts dot JSON. So now we see that it prints the head, the first few lines. So Kelly Brace's object ID field name, then colon, then object ID, comma, unique field, colon, then the Kelly Braces, then we have name, colon, object ID, is system maintained, colon, true. So and then we have global ID field name, colon, space, fields, colon, and then this will list the all the fields. Okay, so now we will go back to this R. Okay, so now we have we are going to do some R functions. So get the JSON into R. So first we will load the library JSON library bracket JSONlite. Let our JSON equal to from JSON bracket read lines bracket the name of the file traffic dash daily dash counts dot JSON, and we check the length of our JSON. Let's do that, and that's 6. There's a warning incomplete final line found on daily, so final line is incomplete. It's okay. Now so let's check the what is being in the RJSON. So head sorry, we'll just do RJSON. Let's see what it prints. So we see the data frame. So we see column 1, column 2, column 3, column 4, column 5, column 6, column 7, and then we'll have column 8 attributes. So 3, 6. Okay, so the length of the RJSON is 6. The sixth is the one that we want. So we need the 6th component data frame from the list, and the 6th component gives the values of the attributes. So let traffic equal RJSON double square bracket 6 at attributes, and we print the first few lines head of traffic and then prints this. So we have 3, 4, 5, 6, 7, 8. Then one small detail is that the start dates are numbers milliseconds since 1st of January 1970, but we can convert them to dates. See this start date? So these are in milliseconds. Let's from 1st of January 1970. Let's convert to these two dates. Let's convert to New Zealand dates. So let traffic at start. So this will create the new column equal s dot POSIX POSIX LT of traffic at start date divide by 1000 because that's in milliseconds. Now we want to find the seconds, and then comma we convert it to the dates by putting origin equal double inside the double apostrophe sign. We'll have 1970-01-01 comma tz equal inside the double apostrophe sign we'll have nz. So traffic square bracket comma continuous start date comma start. This will print the columns from the traffic start date and start. Let's run that. So here it is. Now if we look at the head of the traffic start, traffic at start, then we see the values. We see that it is a date first, and then the time, with the hour, minute, and with the seconds, and NZDT for the New Zealand date time. Then note that this data source contains 2000 traffic counts. Let's have a look. We check the dimension of traffic. There are 2000 rows and 11 columns. Let's run it. Explore. Now to explore the data, we will create some plots. The data are from 2 distinct days, unique of traffic at start. So let's look at the unique of traffic dot starts. So there are 2 dates that the traffic that the data is from. The 1st of January 2018 and 2nd of January 2018. Now we will plot histogram of traffic at start. Let breaks equal to 5. So we see that 1st of January, and this is 2nd of January. What if we do breaks equal to? So this is for 1st of January and this is the other one is for 2nd of January. Roughly half data on each day. So let's do a table of traffic at the start date. Let's plot the histogram of traffic at the start date and let breaks equal 5. So we see, let's do breaks equal to. So there are 2 dates in milliseconds and the half data on each day. So we have 1108 and 892. Then there are just over 500 different sites, so only a few observations per site, though definitely more than one per site. So length of unique traffic at site ID. We run this. Plot unique of traffic at site ID. So that will be on the x-axis, and the table of traffic at site IDs. So this is the number of site IDs on the y-axis, and we want to also print maximum of traffic at site ID. Let's have a look. So the length of the unique site IDs are 396, and the maximum of site ID is 478,051. And we have on the x-axis the unique site IDs, and those are the 396 unique site IDs. And on the y-axis we'll have the counts of those site IDs. So we can see there are only few observations per site. The range of the y-axis, the counts, is ranging from 1 to this number might be 20. Let's find the maximum of the y-axis. Table. Traffic site ID. index 20. The maximum is 20. And the minimum of the count is 1. It appears that for some sites there is only data for one day, but other sites have data for both days. To see that, we will plot x equal traffic at start date, comma y equal traffic at site ID. We also want to form a table of traffic at start date, comma traffic at site ID, and we are printing from 1 to 20. So let's have a look. So we can see that some of the site IDs are for one day, and some of them are having for both days. Let's look at the plot. The plot shows that we have start date on the horizontal axis and we have site ID on the vertical axis. So there is one date having site IDs on both. There are site IDs on both days, and there is a site ID only on one day. Plot density of traffic at traffic count, comma the main title equal histogram with density line on the traffic count data. So we are plotting the density of the traffic count, and we see that for the density line, we see that it goes steeper and then it falls down. It looks like it is right skewed. The traffic counts are skewed as we would expect. This probably reflects the fact that we are looking at daily counts rather than the 15-minute intervals. Okay, let's transform the data. Now for the transformation, we will do square root of traffic count. So let's plot the density of square root of traffic count. Color equal COL equal red, and the title main equal histogram with density line on the square root of traffic count data. Let's run that, and we see that is skewed less. Definitely it is skewed less. So a square root transformation does a reasonable job, though it suggests bimodality. Plot bimodality because we can see two modes. This is one mode, and this can be another mode. Plot density of square root of. So what we want to do is, in this one, we want to subset the light class weight from the traffic, and then we want to look at the corresponding traffic count, and we want to plot density. So plot of density of square root of subset of traffic, comma class weight equal light bracket at traffic count. So close the two brackets. Color equal green. Main equal histogram with density line on the square root of traffic count of \n means new line, light vehicles data. So when we run that, we get this. Plot. Then we plot for heavy vehicles. So first from the traffic data, we subset the class weight equal heavy. Then from that subset, we look at the corresponding traffic count and we take the square root of the traffic count. And then we find the density and then we plot the density and we'll color that green. Main title equal histogram with density line on the square root of traffic count of \n means going to the new line, heavy vehicles data. So we see this. Now if we compare the light vehicles and heavy vehicles density plot of traffic count, this range from about 0 to 150 and for the heavy vehicles range from 0 to about 30. Once we split into heavy and light traffic, we have quite reasonably behaved data.